Welcome to Mathematics Lecture Series, lecture number 4, Types of Function in Applied Calculus series. So, types of functions, surjective functions or onto function. From x to y, a function is said to be surjective if range of f is y, means whole codomain is range of the function, means every element of codomain are imaged from the set x or from the domain, then this function is known as onto function. For example, f of x is equal to x cube. Here from R to R, this is onto functions, means for every element from the real number we have the unique element from the real number, whereas the function f of x is not onto because codomain real is not a range. This is for every element of it we have just a non-negative real number. So f of x square is not a onto function. Injective or into function. A function f from set x to y is said to be injective if distinct element of domain of function df have distinct images, means distinct element have distinct images. Suppose that x1 x2 belongs to domain of f. If they are different, if they are same, if they are same, x1 is equal to x2, then images are also same, f of x1 is equal to f of x2. So this is equation of injective function. Injective function is also known as one-one functions. For example, the function f of x cube from R to R is one-one function because distinct images have every distinct element from the domain have distinct images because different values of x have different images in f of x, and f of x square from R to R is not one function or injective function because x is equal to 1 and we have the image y is equal. If x is equal to minus 1 and y is so, two different elements have the one image, one same image, so this is f of x square is not one function. Bijective function. A function f from real to real is bijective. It is injective and surjective. A bijective function is also known as one-to-one correspondence. For example, the function f of x cube is a bijective function. Here are some examples uh, for the types of the function. So just general function, every element has unique images. This is example of injective function. Injective, not surjective, means injective. The definition of injective functions is that different element have different images. You can see that different element have different images, and this function is surjective because this b all elements are imaged from the domain set A. So this is a surjective, but this is not injective because of that these two elements have same images. So this is not one to one, but it is surjective onto function. Observe that that is a bijective, injective and surjective means two. Here first for surjective onto B is a codomain, and it is also range because every element B is an image from the set element a set element. Here if you observe that different element have different image, that's why it is injective also. So if it is injective inside so therefore it is bijective. Now even and odd function. A function y is therefore said to be even if satisfy f of minus x is equal to f of x. So if any function satisfy this equation is called even function, and if f of minus x is equal to minus f of x, if we write any function in that way, so that function is called odd function. For example, x square plus 1 f of minus x, if we replace x with minus, is minus x square plus 1, so minus x square plus 1, so we have f of x. So f of minus x is equal to f of x means it is even function. Now f of x is equal to x cube plus x. Now after that, if we replace x with minus, it's minus x cube minus x. So minus x cube, we can write minus x cube minus. So we reckon the minus is a common, the rest is x cube plus x minus, what about this? This is f of x. So f of minus x is equal to minus f of x. So that is x cube plus x is an odd function. Now if we have the f of x cube minus x, this function not satisfy these even function equation and odd function, so that is neither even nor odd functions. You can verify it yourself. Now observe some examples here. If even powers function x square, x4, x6, if that k is greater than 0, if k is greater means power of x is a positive, so we have this graph. If we observe that on x-axis, if x-axis goes to minus infinity, then we have this one is goes to f of x goes to plus infinity. If x goes to positive infinity, then branch this goes to f of goes to positive infinity. So you can observe even power of k is less than 0 means if we have x power minus 2 or x power minus, so we have this branch. If x goes to minus infinity, then we f of x goes to minus infinity. If x goes to infinity, then that f of x goes to minus infinity. In both where it is goes to minus infinity of the y-axis. You can observe this odd power. If k is greater than 0, we have this function, this graph. If x goes to minus infinity, then this graph goes to on the y-axis, f of x goes to minus infinity. If this goes to positive infinity, then this branch goes to y-axis into direction of positive. F of x goes to positive. Similarly, you can see that inverse of a function. Let y is equal to f of x be a function of x. We define inverse function by that way x f inverse. So just taking inverse f of inverse both sides. So f inverse identity, here we have the x and f inverse y. Now y is equal to x plus 2 upon x minus 7. Now taking the inverse of that function, so y is equal to f of x. So we here divide, multiply both sides x minus 7. So y x minus 7, x plus 2. Taking multiplication y x here minus 7y, so we add both sides plus 7y, we have the plus 7y. Here x we minus x and plus 2. So if we taking here x is a common, so rest is y, here is minus 1. Here 2 plus 7y. We have to find x, so x taking divide both sides y minus 1, so we have 2 plus 7y, y minus 1. What is x? X is a f inverse y, so f inverse y is 2 plus 7y over y minus 1. Must note that if y is equal to f of x be a function of x, then its inverse x if f inverse y may or may not be a function. You must know that if y is equal to f of x, then its inverse x if may or may not be function. f inverse y is a function only if f of x both 1 1 and onto, means injective, and surjective means bijective. That is, if y over y is equal to f as a bijective function, then its inverse x if inverse y is also a function. Moreover, the resultant inverse function is also bijective function. Now observe that y is equal to x plus y. Since this function is a bijective function, of course this is 1 1 and onto, and so x is equal to, if we solve this for x, so x is equal to y minus 5. We just taking 5 on the other side, we add subtract both sides minus 5. X is equal to y minus is also a function. Y is equal to x plus 5 is a bijective function, so x is equal to, we solve this, means here we subtract both sides minus 5, so x is equal to x is equal to y minus also a function. In fact, x y minus 5 is also a bijective. You can check it. It is very easy that if we, for every y we have a unique element, different element have different images, and all real number are possible if we taking x from the real number. Now consider another function y is equal to x. Its inverse x is equal to plus y plus minus square root y. It's not a function. That is the inverse of that, but it is not a function, because for one value of y there are exactly two values of x. So a different element have same image, so it is not injective. That's why it is not a bijective. So inverse of that function is not a function. In this lecture we have covered types of function: injective, surjective, bijective, one even and odd functions, and inverse of the function. So watch the video and subscribe the channel and like the video as you find more videos on the mathematics topic. Thank you.